we will discuss the factors affecting chemical rate of chemical reaction. Factors affecting rate of chemical reaction. First factor is nature of catalysts. Nature of reactants, sorry. So the nature of reactants, it depends on the nature. If it is poorly bonded with other atoms, it will become easy to us to remove and to break the bonds and combine with other molecules of the reactions. So it will depend on the nature of reactant. Second, surface area of reactants. If the surface area is high, for suppose if we take a big plate and if we pour a water in that, evaporation will occur quickly, so the rate of reaction will complete in a faster rate. If we take a coffee cup, rate of evaporation will slower, so the rate is proportional to surface area. Third, next, catalysts. If we take the reaction as A, for suppose A plus B gives rise to C plus D. If we perform this experiment, if we perform this experiment without the presence of catalyst, it will take 10 minutes. 10 minutes without catalyst. If we perform this with the help of a catalyst, it will take 5 minutes. So the rate of reaction will completed in a shorter time with the help of catalyst. Now, temperature. As the temperature increases, the rate of reaction will increase because the temperature influences the bond breakage of the chemical reactants. So temperature influences. Fifth, what is the fifth one? Concentration of reactants. Now, if we take the smaller quantity of the reactant, for suppose 5 grams, if we mix with 5 grams of milk, 5 grams of water with 5 grams of sugar, it will dissolve easily. If we take 10 grams of water and 50 grams of sugar, it will dissolve in a late time. So the rate of reaction depends upon the concentration of reactants, nature of the reactants, surface area of the reactant, catalyst, temperature and concentration of the reactants. Now we are going to discuss the differential rate law. Differential rate law. It is applicable only for the reactants only. Applicable for reactants only. Now, if we take an example, A plus B gives rise to any products. Now, if you apply rate is directly proportional to A to the power of X. The power may be the stoichiometric quotient or may not be the stoichiometric quotient. b to the power of y. Now rate is equal to rate constant k into a to the power of x, b to the power of y. Now if we take the rate of disproportionation of a minus dA upon dt is equal to k into a to the power of x into b to the power of y. Now the rate law states that how fast the reactants converted into products, or sometimes it does not tell how much time will it take to convert into the products. Now the rate law states that now we will take the summary of this differential rate law. It is applicable for reactant only. For example, if we take the products like this, AA plus BB plus B is to products, rate directly proportional to a to the power of x. Here one the important point here, x may be the stoichiometric quotient of the reactant or may not be the stoichiometric. For example, if we take the equation H2 plus I2 into the products gives rise to 2HI. Now here rate is equal to k into HI whole square. Now as you see here, the rate of reaction is the power here is equal to the stoichiometric quotient. So as you see, the rate of the power here is maybe stoichiometric quotient or may not be stoichiometric quotient.